Hello friends, welcome to Learners Forum. So last video was about KCL and KVL. In this video, let us see the topic mesh analysis. So to understand what is mesh analysis, we should know what is mesh in first. So it is defined as loop without inner loop, which means if we consider a loop in this way, it should not have any inner loop. But in this condition, we have two inner loops, that is within the outer loop we have got two more loops inside. So a loop without inner loop will be called as mesh. So this is the basic definition of mesh, and only for mesh we can apply this analysis. So the steps to be followed are, the first step is we have to identify the total number of meshes, and for each mesh we have to assign the mesh currents. So if we have the number of meshes as 3, and we can write the mesh currents as I1, I2 and I3 in this way. So this is the first step. Second step is we have to develop KVL equations for this particular mesh currents I1, I2 and I3. And the third step is we have to solve these KVL equations to find the mesh currents, which is I1, I2, I3. So we have to calculate these currents value. So this is the procedure for mesh analysis. The important note is it is applicable only for planar network, that is no crossover, which means if we consider a circuit in this way, here there is a crossover or line between the other thing. So for such conditions we cannot apply this mesh analysis. So only for planar networks we can apply this mesh analysis procedure. So this is an important point to be considered. We should check whether the given circuit is a planar network or not, and only then we can apply this mesh analysis. So now let us solve the problems based on these steps so we can understand it better. First question, find the power loss in 10 ohms resistor using mesh analysis. Given is a circuit. So let us apply the steps one by one. The 10 ohms resistor is here. So across this we have to find the power loss. So the first step is we have to identify the number of meshes in the given circuit. So looking forward, we can identify that we have one loop here. So let us consider this as one mesh and this as the second mesh. So in the first mesh, consider the current flowing as I1, and in the second mesh we can consider it as I2. So this is our first step, which means we have got two mesh and two mesh currents. So the first step is number of mesh, which is equal to 2 here, and the mesh currents which we have assigned are I1 and I2. So this is our first step. Second step is we have to apply KVL for these meshes separately, and we have to obtain the KVL equations. First, let us consider the first mesh. So starting with the 10 volt supply, since it is moving from minus to plus, there is a voltage rise, so plus 10 volt. Next branch element is across this 5 ohms resistor. So the current flowing across this resistor is I1 in this direction. So since it is from plus to minus, the value of current is I, and there is a potential drop, so minus 5 ohms. So 5 into 5 I1 will be the value of voltage here. Next, when we are moving here, the current is getting split across these two branches. So here we have to be very careful, because here when it is moving from plus to minus, the value is minus since there is a voltage drop, and the resistor value is 5. Now we have I1 flowing when we are considering this particular mesh, which is I1. Similarly, the I2 current is also flowing across this 5 ohms resistor in an opposite direction. So whenever we have cases like this, we have to remember the basic concept, like which mesh we are considering. So the first mesh is I1, and I1 will be the dominant current, so we have to write it as I1 minus I2, since I1 is the dominant current and we are considering only the first mesh now. So whenever we have two currents like this, we have to represent it in this way. So it is I1 minus I2. Next, we don't have any other elements, so it is equated to 0. Now let us simplify this. So it will be 10 minus 5I1 minus 5I1 plus 5I2 is equal to 0. Dividing it by 5, we will get 2 minus I1 plus I2 is equal to 0, which means it is minus 2I1 plus I2 is equal to minus 2. So this is our first equation. Now let us find it for the second mesh. So starting with this 5 ohms resistor, now the current direction will be from plus to minus. So since it is plus to minus, there is a voltage drop. So minus, resistance value is 5. Now since we are considering the second mesh, the dominant current in this mesh is I2. At the same time, we have one more current flowing I1 in an opposite direction. So here it is I2 minus I1 since we are talking about the second mesh. Next, across this resistance, it is plus to minus. So minus 10 into the current flowing is I2 here. So I2, which is equal to 0. So simplifying it further, we will get, dividing it by 5, we can get it as I1 minus I2 minus 2I2, which is equal to 0. So I1 minus 3I2 is equal to 0, from which we can write it as I1 is equal to 3I2. We can substitute the value of I1 in this equation. So we will get minus 2 into I1 value is 3I2 plus I2, which is equal to minus 2. So solving this, minus 6I2 plus I2 is equal to minus 2. So minus 5I2 is equal to minus 2. So I2 will be equivalent to 2 by 5 amperes. So this is the value of I2 current, but the question asked is for power loss in 10 ohms resistor. So across the 10 ohms resistor, we have to calculate power loss, which is equal to I squared R. So the current value we have to check now, since we have said as 10 ohms resistor, the current flowing across this resistor is I2. So I2 square R, I2 value is 2 by 5 the whole square, and the resistor value given is 10 ohms. So into 10, which is equal to 1.6 watts. So this is the value of power loss in this particular resistor. Let us solve one more example for the same mesh analysis. So the given question is, find voltage across 30 ohms resistor using mesh analysis. So here we have given a circuit and the 30 ohms resistor is available here. We have to find the voltage across this particular resistor. So this is the question. Now the first step is you have to identify the number of meshes here. So let us take it as these two meshes. So the number of meshes available in the circuit is 2, and the current flowing across these meshes is I1 and I2. So we have two currents, I1 and I2. This is the first step. So the second step is we have to form the KVL equation for each mesh. So considering the first mesh, starting with the 20 volt supply, since it is from minus to plus, here we have a voltage drop, so plus 20. Next, for resistor there will be voltage drop, so minus, since it is moving from plus to minus, value is 5, and the current flowing is I1. And when the current is flowing through this particular branch, like we have seen in the previous example, two currents will be flowing across the same resistor, but we have to consider which is the dominant one. So minus 10 into, since the dominant current is I1, minus again we have the other current which is I2 flowing across the same resistor, which is equal to 0. Now let us simplify this. 20 minus 5i1 minus 10i1 plus 10i2 is equal to 0. Let us simplify it further. So minus 15i1 plus 10i2 is equal to minus 20. We can divide it by 5. So we can get a minimized equation minus 3i1 plus 2i2 which is equal to minus 4. Let us keep it as first equation. Now for the second mesh, similarly we can start with the 10 ohms resistor. Now the dominant current will be I2 here flowing across the resistor 10 ohms. So it will be minus 10 into dominant current is I2. So I2 minus I1. Next across the 30 ohms resistor value is minus 30 into current is I2. Again from here minus to plus, so plus the value of voltage is 80, so 80 is equal to 0. Simplifying this equation we will get minus 10i2 plus 10i1 minus 30i2 plus 80 is equal to 0. So here simplifying it further, 10i1 minus 40i2 is equal to minus 80. Dividing it by 10 we will get I1 minus 4i2 is equal to minus 8. So this is the second equation. So now let us solve the first and second equation to get the value of current. So here we have got 2i2, here it is minus 4i2. So we can multiply the first equation by 2. So we will get minus 6i1 plus 4i2 which is equal to minus 8. And the second equation is, we can keep it as such, which is I1 minus 4i2 which is equal to minus 8. So this term will get cancelled and here it will be minus 5i1 which is equal to minus 16. So I1 is equal to 16 divided by 5 amperes. So this is the value of current I1. We have to calculate the voltage across 30 ohms resistor, which is I into R. The current flowing through is V is equal to IR is the general formula. So the voltage across this particular branch will be current, which is I2 into R value. So we have got the value for I1 only. We have to calculate the value for I2 now. So I1 plus 8 is equal to 4I2 from the second equation. I1 value is taken as 16 by 5 plus 8 which is equal to 4 into I2. Simplifying this we will get I2, that is 4I2 which is equal to 56 by 5. So I2 is equal to 14 by 5 amperes. Now let us solve for this equation, which is 14 by 5 into R value is 30 ohms. So cancelling 5 and 30, we will get 14 into 6 which is 84 volt. So the voltage across the resistor 30 ohms is 84 volt. So this is how we have to solve this question using mesh analysis. If you have any doubts, you can post it out in the comment section. Thank you so much, friends.